So I will be speaking about Go and why I like it. And my plan is to say why I like Go, and because I didn't like it always. Sometimes ago I was not such enthusiast of Go as I am now. So maybe I will when I show you how my attitude changed over time, you can go the similar path. And during the process, I want to expose you to some small snippets of Go code, because I hope that when you see them, you will like the language as well. And well, finally, I hope that as a result, you will be walk out as a huge Go enthusiast. Well, hope so. So the three big points which I have here is generics, code vendoring or more general tooling, and little of concurrency. And these are the three topics which are the most important for me in my day-to-day work. Or maybe about the generics, they were most important to me when I joined Go. So a little about me. I've been programming in Go for 4 years. I've been programming in other languages previously. I mostly did web applications, and right now I'm in Ingrid, and we do e-commerce with microservices talking to each other by gRPC. This might give you some, this background might enable you to relate somehow to my story, and because when you come from embedded field, some parts of Go might be more natural to you than for me. Okay, so how did I start liking Go? So 4 years ago or something like this, I've been programming in .NET, and I've been enjoying this very, very much. And when I was writing code, I was relying on generics, and I was enjoying writing code with generics very much. It really gave me pleasure to create those complex types with generics. It was fun. And then a friend of mine was recruiting to a startup, and I thought, wow, it's cool to join a startup, so why don't I do it? And they were programming in Go. And I switched from this very object-oriented, I would say generics-heavy language, to Go, which is simple and does not have any generics. And well, I've kept asking myself a question: how can I work in this situation? How can I work in a language which does not have generics? It was a real problem for me. It seemed like a real problem. And well, I will give you some answers. And the first answer is that, well, Go actually has some generics. So here's a first snippet of Go code. So first I create a map, then I iterate over this map, and I put keys to one slice, and I put values to another slice. These keys values is called a slice. This is a Go, this is kind of a list or dynamic array. I think this is the best word for this. And when you see it, it's a generic code. I mean, the map has generic keys, generic values. The slices, which keys and values are generics. I mean, you can have any type inside a slice. And append is a generic function. What append does, it takes a slice, it takes a value, puts this value into a slice, and returns the slice, just like here in lines 11 and 12. And well, I can do it with other types. So map can previously map was from string to int. Now I have a map from int to string, and it's all, I would say it's generic, and it's typesafe. And it's typesafe because, for example, when I put some other value into append, compiler will complain. It will not allow me to do this. So the first answer is that, well, there are some generics in Go. It has 3 generic types. It's map, slice, and channels are for concurrency. I'll be telling about them later on. Go has some generic functions. I showed you one example, which was append, but they are part of the language definition. You can't, there are built-in functions and built-in types. You can't create new ones. And well, the first answer, which I got from experience, was that they cover quite a lot of cases which you will have in your daily practice. maps and lists, or slices as they are called in Go, are the most important generic types, and well, it could be argued that they are enough. But not always, of course. And the answer to is use generics. And I will now tell you how you define generic, use interfaces, sorry, no generics. Use interfaces, and how interface is a bag of methods, and you define the methods in the interface, and you type needs to implement these methods to implement the interface. It's like every other language, but Go is a bit different because you don't need to say explicitly that you define an interface. You just need to have the right methods. Oh, maybe I will go back. So here's a reader. Every language, I guess, has a canonical reader interface which says how you read from a stream. It's like here's the interface with just one method, read, and it's implemented by the file in the OS package. And OS package defines the read method, but nowhere in the OS package it says that the file implements reader. It will be checked later by the compiler, and I will give you another example. So let's say that for some reason I need to implement a function which reads config from a file. I'm sure it happens to all of you a lot of times. And well, for some reason you don't know the format of this file beforehand. It could be JSON, it could be YAML, so you need to guess the format from the name of the file, and then you read. So here is what this read from file function will do, and you need two things to read properly: name of the file and the read to get the contents. So once I implemented this function, I could use it with the file from the OS package, from the standard library, like this. I open file. This is very simple. Then I check for error if it opened find, and then I just use the file in my function. The whole wrapping of the file into my interface, which I defined, is done by the Go compiler. And it can save a lot of problems. And this is also Typesafe. So compiler checks whether the type which I pass to the function has all the methods defined. So for example, here I used the reader from string. So it will just return the standard reader, only does not read from file, it reads from string. And I cannot use this. I cannot pass it to my function because the compiler will complain that there is no name method. And one of the, I would say, places where generics are most natural to use is sorting, because sorting is a complex procedure. I mean, it's not something which you will likely to implement yourself. At least not very often. Well, I haven't done it yet, because it's usually implemented in a standard library in a good enough way. So how do you sort without generics? Because a lot of implementations of sorting which I used relied on generics. You either had some compare function which compared with a generic, or you had order by which returned some type which was used for ordering. And how do you do it when you don't have this? So there is package sort. Go has very nice names, so it has package sort, and it defines interface. And you read it sort.interface, so you rarely use this interface alone. You will always use it like sort.interface. So it's not that. In other languages, I guess it would be not natural to call interface. Here it's more natural. And what this interface defines? It defines three methods, and they more or less represent, I would say, how you operate with an array or a list. So you say how long is the list. You say it's the first method. You say how you swap elements in the list is the last method, and you say how you compare two elements in the list, and how you use it in practice. So let's say we have students. Here are defined student type. Students somehow has the average score. It's somehow computed, and then we want to sort students by the average score. How do we do this? Well, you define a new type. I call it students by the average score. It has an underlying type, so it's not an. It has a slice of students as the underlying type. It's not alias. It's an underlying type. And by the way, here's I used a third time type definition, which we have in Go. So in Go you have you can have type as interface. You can have type as struct, which was a student a few slides ago, and here you have a type with an underlying type, and this type has these three methods, and len and swap are quite obvious to implement, and well, less is also quite simple. You just take two elements from the slides and you compare them, and this works like this. So sort by average score works in place. I first, on line number 2, I first cast or coerce students into my type, and then I pass this type which implements sort.interface to package sort, and it works. And well, you could do it in one line, by the way. I only introduced this variable line number 2 to make it easier for you to read. And this solution works. It sorts. It's generic. It's not generic, but it's type-safe, which I think is quite smart. I mean, you can have type-safe sorting without the generics, and it's readable. I mean, once you know that the interesting part is the less function, it's readable. But for me, it was very tiring to type. I mean, what is wrong with this code? You need to define a type. And the problem with defining type like this is that something will complain during the code review. Well, why didn't you give it another name? At least that's what happens to me a lot. And then the len function is repetitive, and writing repetitive functions is tiring. And then the swap is repetitive. And the only interesting part is the less function. And also, the problem with the repetitive function is that they are omitted during the code reviews. It's easy to make mistakes with them and forget about them. And when you see it on the line number 16, there's a mistake. You don't actually swap. So all the elements remain in place, and here it's fixed. So there's a problem with repetitive code, and how can you solve this? Well, you can improvise, and it's all that is left now. So in Go 1.8, a new function in sort package was introduced. It was called slice, and accepts slice as empty interface and a less function. And let's take a deep breath and look at the interface, because I think it's very elegant. So interface is a backup methods, and empty interface is an empty bag. It has no methods you need to have to implement this interface. So any type can be casted, used as empty interface, because there are no methods you need to have to implement empty interface. But apart from this elegance, empty interface is something like object in Java or object in .NET. So you use it when you have no better idea what to use. So this is how my sort students by average score looks like when I use sort.slice. So the first function is passed as an empty interface, so it's not type safe. This function will panic, which is like throwing an exception but worse in Go, if the students is not a slice. And the second one is compare function, which is then, I would say, type safe. And I mean, the whole point of generics is having a type-safe code, and now you don't have a type-safe code because you pass students the not type-safe wave. But I have seen a lot of problems during my career on production and in different stages, but I have never seen this one causing problems, because usually when you pass something as a first argument, it's easy to check in the code review stage, and well, usually you don't have conditional logic. So one, it's if you pass something wrong, it will complain once, and then the second time you will pass the right argument, and it will just work. So with sort.slice on board, I would say this Go covers a lot of cases. Here's another totally made-up number where generics would be needed, and there are some cases left, and it's true. And well, how can you solve them? Here I showed you how this can be solved using the built-in function, using the the standard library function. How they did it in the standard library, so using the reflection. Other people argue that you can use code generation or simply copy-paste. And well, again, in my experience, the copy-paste is usually the simplest and not that bad method. I use it from time to time. I use reflection a few times, and well, I have never written a code generator. Even though it's fun, it's always fun to write code generators, but I have never written one. But I used a few. And what about the copy-paste? Isn't copy-paste bad? I mean, that's what I was told all those times. And usually it's bad, that's true, but to some amount it might be beneficial. In Go, there's this saying that it's better to have a little copying than a little dependency. So when you copy the couple sort of your code, the two copies can grow in an independent way. And well, there's a trap here that you can start worrying too much about copy-pasting, about not having generics, or this kind of stuff, and when you spend more time worrying, Googling for how to solve a problem, or wishing for generics, when it will take you to actually write the code, which is a little boilerplate. I mean, that's at least what happened to me. And I will now talk about the copy-paste method, which might be the very first time you be on someone advocating copy-paste, or maybe not. So I think any modern language like right now has something which is called atomic. Atomic is for setting atomic references. You have atomic ints, so you can atomically increment an integer, for example. It's used for the concurrent environments, and yeah, so Go has that. Well, Go has the atomic package and has atomic value. You can store value to the you can store something to this value. You can load from it. It's now not type safe. It's yeah, as you can read in the comments, the runtime checks whether ensures that you can store different values, different types, sorry, to the same value. But it's all. When you see this atomic dot value in the code, you can't know what type it holds, and it can lead to error. And how can you solve this? Well, you can wrap it. Of course, in language with generics like Java, atomic value would be a generic type. You could store a generic value there, and get load would be a generic value returning the specified type. In Go, it's not possible. What is possible is to write some code. You can write a wrapper for if, let's say, we want to store strings, we write a wrapper, and this code is still not type safe. So on line 10, you can see that I cast. If this cast is for some reason would not succeed, my program would break. But well, it's easy to see during the code review or when you look at the code that it's fine, because the distance between where you store and load is 4 lines. So this is very, very close to each other. And well, of course, this is works very nice, but now when I want to store time instances, I need to copy paste, and this is bad. But I would argue that in a lot of projects which I had, this not happen that often. So for example, when I write a service, the service will have 1 or 2 atomic stores at most. I mean, 2 is, we use microservices, so I guess 2 is the biggest maximum I ever saw. And it's not that bad. Maybe it's a Stockholm syndrome, but still. And when you need another type, which holds maps, you need to copy paste one more time. And here's one, I would say, problematic part about it, because I called it a map value, but when it gets complicated, it's when, for example, in the same project you want to have 2 values, one which holds map string to string, and the other one holds map string to int. And here it gets messy, because you end up with names like map string string and map string string value and map string int32 value. So here is where things start to get messy, I admit, but here's a simple example. So it's the same as the 2 previous ones, but here is a atomic values solve a particular problem with concurrency, storing references. But here is another room for error in this code. Maybe it's not so obvious, but in any language I know, or most of the languages I know, at least non-functional ones, maps are not safe for concurrent use. You can read concurrently from a map, but you cannot update concurrently a map. So what could happen here is that we have a map value and one goroutine, which goroutines are sort of threads. I will go to that later. Someone puts value to this store map, and then 2 routines take this value and update it concurrently, the same value, and it's an error. You can't modify value map concurrently. You need to copy it first before you update it. It's I think it's like in a lot of languages. So this map value, I mean, what it does, what it advertises, it stores the value reference concurrently, but it still has room for other errors. We didn't have this problem previously, because the previous values which we stored were unmutable. This one is mutable. So we will have this problem for each mutable value. So maybe this map value should be written in a different way. Maybe you should clone this map before returning it. Well, this might have some performance burden, that's true. But still, we prevent ourselves from some kind of an error. So what I'm trying to argue here is that there is less copy pasting in the world than you think. But sometimes you think there's some common logic, but it's not as simple as you think. Okay. And there is, I will now talk about building Go applications and code vendoring, and this is food vendor. I couldn't find anything which resembles code vendor. So I really like writing in Go, and I really like Go tooling. So Go has fast build times, and dependencies are distributed as a source code, which is not like this in other languages. In other languages I programmed before, it's true for some languages, but I'm talking about this because it's new to me. So here is when my background is a little important, because I know that for some languages distributing as a dependency as a source code is very natural, but it was new to me, so I wanted to share this with you. And in most cases in Go, a dependency is a Git repository. So it's funny because you use some different kind of, let's say, entity to talk about your dependencies. You don't have the module system or jars or something like this. You have Git repository, something which is well established, or directory in a Git repository, and because of this you can reference your dependencies either as Git hashes or Git tags. And here's a sample structure we use in our services. And the three entries which are important to you right now is go package, log, tom, and vendor. So in vendor we store the source code of all of our dependencies. We commit it to the source control. I will talk about it later. And the other two files are, well, I think they are standard things. So log file holds the exact versions of all dependencies. So it will be either git, it will be git hash, sometimes accompanied with the tag. And tom stores the rules, which says something like this SQL library needs to have at least version 1.4. And what is important, this log file stores the transitive dependencies as well, which is also very convenient, at least to me. And this is to give you more overview how this vendor directory looks. I listed it, so you can see that we have directories which represent more or less URLs of the repositories. We have 4 repositories here. We have some, for some of them we only store root, and for others we also store some subdirectories. And we have source file, all source files which we depend on in this vendor. And I would like to make this one thing clear, that adding vendor to source control is controversial, even in Go community. It might go away at some stage, but I like it so much that I wanted to include it also here. So usually when you download, when you come to a new company, you check out their project, you run build, and then there's this phase of downloading the internet, because you need to download all the dependencies. Half of the internet traffic is npm install. And in Go, when you add vendor to source control, the internet is already downloaded to your laptop when you are finished with git clone. So it has a lot of benefits, like your CI only needs access to source control. And when the dependency disappears from the internet, your build will still pass, and we all know that this happened, for example, to the JavaScript community when the left-stat library was taken from the internet, and it was a transitive dependency of a lot of builds, these builds ceased to pass. Last thing is that adding vendor to source control mostly makes sense for things which run like services and command line tools, not for libraries. And the downside of it is that, well, you can have this competition of whoever will create the biggest pull request, and here one is 500,000 lines change, and it's not the winner. But the tooling is getting better with this. So in like 1.5 years ago, GitHub UI would cease to operate on such big diffs. Now they are getting better because they are hiding files which are inside vendor. So it's not that problematic, at least for me, anymore. And it's when you use your dependencies this way, it's very easy to keep things in control, not only for your root dependencies, but also for transitive dependencies. So what I did here is on one of our services, I ran update, and well, by the way, what I'm using is unofficial Dependency Manager tool, which was an official experiment from Go, but now might not be continuing in the future, but we are very happy with it. So you keep using it now. So back to the subject, I updated one dependency, and it cascaded into a transitive dependency update. And you can see that this tool outputs how each tool changes version. So we don't do it right yet, but it's really tempting to include a if this dependency is hosted on GitHub, to include a link which shows you the diff between the old version of the dependency and the new one. Or you can use it in your command line using git log or git diff. So I think this is it gives me the confidence that I can see how my dependencies are changing. And this is one of the most important things for me in Go, but it's, as it happens with the important things, it's hard for me to express sometimes. So Go is a simple language, which means that it should be easy for everyone to read. I hope that it was obvious for you when you saw the snippets before. If not, it's probably my fault. It's strongly typed, so it means that my code editor likes it, because it can follow the references easily, and also it's easier for me to analyze. Dependencies are distributed as a source code, which has additional benefit that they are always at your hand. What happened to me, maybe in the old days of development, is that I only have the binary of the dependencies, but the sources was not that easy accessible. And now I can have sources in my code editor. And Go has a general preferences of libraries over frameworks, and maybe it's hard to discriminate between the library and the framework. But what the key point here is that before I started programming in Go, when I had a problem, like something wouldn't work, I would go to Stack Overflow, and I asked a few questions on Stack Overflow, not that many. But they are still getting votes, and they were all very bizarre. And I did something, and in something seemingly totally unrelated piece of code didn't work. And now, when I have a problem, like I call a library function, because maybe the difference between the library and the framework is that in Go you usually call functions instead of some magic happening somewhere. When I call a function and it returns an error, and I don't understand what have happened, I grab for this error in my source control, in my vendor directory, and it's very convenient. I was quite surprised, because when I joined the language, I joined Go programmers, or people programming in Go. I thought that I will be asking a lot of questions on Stack Overflow, that I'll be gaining a lot of reputation for Stack Overflow by asking a lot of wise questions. I always was really into it back in the days, but then I was quite surprised to learn that I haven't asked a single question about Go in those 4 years, and it was because, well, most of my questions I was able to answer them myself, but simply looking by the code of the dependencies or into the code of the standard library. Because the standard library is also distributed as code, and well, by the way, it's very fun and very entertaining and nice read. Reading standard library was very good experience for me in Go. And I've heard a few times that you should start learning language by reading its standard library. That it's, the standard library sets the standards. How you should program, but only in Go I was able to use in practice. And concurrency, and if you don't get the joke, I will explain to you. These are threads in this box. So, Goroutines, or maybe before that, concurrency. So when Go is advertised for concurrency, you usually mention two things, which are Goroutines and channels. And I think Goroutines are more important, but channels are very nice too. And I'm now going to give you a crash course over these two, so I hope that we will all manage it. So Go has Goroutines, and Goroutines are not, you can think about them as the lightweight threads, that it can be a bit misleading. So Goroutines are managed by the runtime. You will have a lot of Goroutines, and usually about the number of threads is equal to the number of processors you have, maybe the number of processors plus one. I remember that there was some black magic maybe not debate what's the default is number of processors, and you will have thousands or millions of Goroutines, because Goroutines are very small, and I'm not a Java expert, so I was not sure if it's a good idea to put a Java number here, but I have a reference for this in the Oracle documentation, so I hope that I'm safe on this one. And it's a default value, so you can make it smaller, but you can compare 2 kilobytes to 1 megabyte. 2 kilobytes of Goroutine in Go and 1 megabyte in Java. You can see by this how many more you can have Goroutines than you can have threads in Java. And because of this, you usually don't care about Goroutines that much. You won't have pools of Goroutines, you won't have any async, because you just keep creating new Goroutines. This has the downsides as well, because sometimes you have a Goroutine leak. So you start a Goroutine, but for some reason it never finishes, and because they are small, you don't see it immediately, and they start stacking slowly, and then you start wondering why your application is having memory problems like 1 week after it's deployed to production. But you should always be careful. And here are channels, crash course. Channels are, the official documentation says composable pipes. I would say it's priority concurrent queues. At least that was my first impression. So first I create a channel, then I create a Goroutine. You can see how it's, I would say it's simple. So you just write a function, and you write a function call, then you write a Go before this function call, and it's run in a separate Goroutine. So in the separate Goroutine, I send value to a channel, and then in the line 8, I receive value from this channel. And these two will block, so 4 will not be executed, so the value won't be sent into the channel before someone can take value from the channel. So channels can be used for sending data, they can be used for some kind of synchronization. But what's most important about channels, and why they are not simple concurrent concurrent queues, is that they are composable. So here I have a piece of code, and it's called I have 2 channels. In one branch I'm trying to write to one channel, in other branch I'm trying to read from another channel, and whatever first is possible to do. So when I have empty room in the first channel, or I have a message in the second one, this one will be executed, and otherwise it will just block until one of these 2 actions is possible. And if the blocking is not desired, you can also put a default branch. So this will check whether one of the 2 first actions is possible, and if it's not, it will immediately execute the default action. So I hope it was clear. And now I'm going to my ultimate piece of code here, so you won't be seeing anything more complicated, at least on this talk. So first I'll create a type. And this one is really a tuple. So if in a language with a tuples, I could use a tuple, but here I need to define my own, but it's not that much code. This tuple can hold either a user or an error. Okay, and what I'm trying to achieve is I will be fetching a user by ID, but I assume that this user can be either in the cache, say Redis, or is some external service, and I will be calling both and getting the result from whoever answers me first. You probably don't do it very often in the real world, but you might do something similar. And I create 2 Goroutines, which call 2 different services. I fetch the results from both of them, and then I wrap these results in my newly defined type, and on line 16 I read from the channel and I return the error. So one problem with this code is and yeah, the important thing here, one of the important things here, is that you don't use any pools, you don't use any async. The whole of this code is, I mean, each function is synchronous, and all you don't care that much how many Goroutines you have, unless providing that you finish them properly. And one problem with this code, business-wise, is that if, for example, cache is not available, like Redis is right now down, it will return an error immediately, and I will return the error because the Redis will be probably first to answer that it has no value. So, sorry, the other problem with this code, I will handle this one in the next iteration. In this iteration, I handled that it's both that this code can timeout. It can take too long to answer. So I will be composing two channels. First, I take the channel from the standard library, which is called Timeout, and this standard library will put a message to this channel after 2 seconds, and then I use select to get the message from the first channel which receives a message. So if it's result, I will return the result, and if I first get a message from a timeout channel, I will return some error indicating that an error happened. Yeah, and as I said before, one thing which could go wrong is that the Redis is down. I mean, this handles a situation where both services are down. Where both services are so overloaded that they fail to answer in the 2 seconds. And here in this situation we return a meaningful error. But if one of them is down but returns an error immediately, we return this error as well. But maybe we could wait for the second service. Like if Redis answers that it's down, then we call the second service. So it gets a little complicated. Now I have a for loop, and I again select from the 2 channels, and then if I get the results, I check how many calls I handled so far, and I mean, if the result has no error, I return it, and if the result is an error and it was my second call, I return error which I received. And it might seem complicated, and it is. But the truth is that, in my experience, it's not complicated enough. Like when the Redis fails, you probably want to get notified somehow that the Redis is failing, and you want to understand how you got with the result. So yes. But still, I was able to write a piece of code which does concurrency and handles timeouts properly using only the standard library and standard constructs. Yeah, and I will be summing it up. So there are a few things which didn't make it to the slides because of the time constraints. And the first thing, which is also controversial, at least for me in Go, but I didn't manage to put into the slides, is error handling. I hope that you saw it in the code, that Go treats errors as values, so it does not throw exceptions. When a function can fail, it should indicate so in its signature by returning a value error. But I also hope that maybe this, when looking at these examples, it was easier to follow, for you to follow them, because you knew that where stuff could fail. Or maybe it didn't, but error handling, especially error handling, didn't make it to the slides. Another thing which didn't make it is saying how Go is great at being cross-platform, and how it's easy to compile it being on Linux, to compile it on Windows. Then Go standard formatter which is like any other formatter, only it's a part of the official tune chain, and it's adopted in all the tools, and you execute it on save. Usually you execute it on saving the file, and it's very, very nice. And another thing which is context.context, which is apart from other uses, is for cancelling the request, and the examples which I showed you would be a bit simpler using it, but still I didn't, it would require some additional introduction, so I didn't want to put it too much. And the funny thing is that generics might come to Go after all. So when this happens, I will probably eat to take the pen drive with these slides and eat it. But the good thing is that I will be in a good company, because a lot of wise people were telling how to program in Go without the generics. But this might happen at some day. Another thing which might happen is dropping the vendor as it is now in favor of the new module system. So the dependencies will be still source code, dependencies will be still Git repositories, but there won't be this Go package file. There will be some other files. In the new version of Go, the present version of Go is already present, experimental support. I haven't played with yet that much to talk about it more briefly. And how can you start programming in Go? So first one is a good advice on anything that you do is to stay open-minded. So Go has a lot of best practices which might be contradictory to what you are doing in other languages. It might be sometimes a little verbose, and well, these practices might not be right on everything. They might not be right on every detail how to write a good software, but still it's easier, I think, and more beneficial to try programming in language with the open mind and trying to absorb the knowledge instead of discussing it at the very beginning. But it's very good to start discussing it after some time. But it's when you learn the new rules, it's nice to see how they work their practice before you start to question it. That's at least what I think. And well, the next part is you can write Go. The next time you would be writing Python script. I hope that maybe these examples which I showed you before convince you somehow to this. So Go can feel very lightweight, especially when you write shorter programs, and because it's statically compiled and because it's typesafe, it's also very easy to start with. And when you are done with your script, maybe you can update it to a command line tool. So we are now in my company, Ingrid, where I work right now, we are using Go for every command line tools. We are writing REST clients in it. We are writing a lot of stuff in it. Or writing microservices or just a service. Go is statically compiled, so it's very easy to deploy it to your server. It is also plays well with Docker. A lot of cloud infrastructure is already built with Go, so it has also the light libraries. Maybe you can build something small in Go. And the final point is once you are done with there are some companies which are hiring, which are using Go, and I think you don't require that much experience with Go to start programming Go professionally, because Go is supposed to be a language which is easy to learn. So if they are programming in Go, they should teach you quite fast how to program in Go. And in any language or in a lot of situations in life which you do, there are a lot of false promises, like do this and it will solve all of your problems with anything. And I would say that some people are making such false promises in Go as well. So concurrency does not solve Goroutines does not solve all your problems with concurrency. Concurrency is still very difficult at very levels, but Go makes it a little easier because, for example, you don't need to worry about having too many threads, or you don't need to worry about that you are calling a synchronous function from an asynchronous function. And also Go has Go FMT solves some disputes about the code style, but we still sometimes have heated code style debates, but at least we are not having them over tabs over spaces. And static typing in general, I like this definition of types that they help in avoiding type system is a way of avoiding some kinds of mistakes. So Go helps you in avoiding some kinds of mistakes, not all of them obviously, but I would say that for me it's quite a lot. And I did software engineering in a lot of programs. Some of them even work, and there are a lot of programmers who can build software in the world. There are people who are making production code with Haskell, for example, or with Fortran or with Cobalt, and well, different tasks call for different tools. So I wouldn't be doing data engineering in Go, for example, but still, when I approach a program right now, may it be professional, but when I want to write some simple tool at home during as a pet project for fun, Go is my first and preferable choice because I like it so much, and I think it's a good tool for a lot of problems. And that's all. Thank you. If you have any questions, that's the right time.
Actually, I have a question about the concurrency with atomics slide.
Okay.
There was a slide where you were returning the map of string of strings, so mapping string to strings.
Yeah. Here it is.
Yeah, and you clone it. So is it like a standard practice that in coroutines you only have immutables, so it's like functionally safe, or is it allowed to like change states in coroutines?
I mean, it depends, I would say, but it's. I mean, it's. I'm not sure if I understand your question properly. So it's not allowed to for two Goroutines to update the same map because there's an error, like in every language. The preferable way for Goroutines to communicate is by sending messages to each other by using the channels. But for example, when I want to implement a cache, this will be done some kind of mutex, for example. So then the Goroutines will be modifying the same piece of the same structure. And maybe I should be put more emphasis on this, that Goroutines, that channels are for communicating, but because they are so advertised in Go, sometimes they are a little overused, I would say. Sometimes when simple mutex would suffice, people are using two Goroutines, and well, mutexes are just fine.
So coroutines are allowed to be synchronized by mutexes or
yes. Okay, so this was your question. Yes, so Goroutines can synchronize using mutexes as well.
Thank you very much.
Here's a question.
Hi. I have one question about the example with fetching the user data from the database and from the cache. It was one of the last ones.
This one, or?
Yeah, this one. And My question is there any way to cancel the execution of Goroutine? Because in this case...
Okay. This is... okay, I'll read to finish.
Because in this case, you are performing two actions at the same time, one that is heavy and one that is light. And when you are having the result from the light source, like from the cache, you want to cancel that is heavy. Because when it's continuing, it's like pointless to have a cache when the real operation is still executed. So my question,
So this is the very good question, and the problem here is that I want to fit a code on the slide, and I want to get within some time limits. But how it would be usually performed is with this context object. Usually what I would do here is I would create a new context object before calling this two Goroutines. Then I would pass this context to the two calls, so get user from external service and get user from cache. And then once I get the result, I would cancel the context. And then I need the code inside each of these two functions, which checks whether the context is cancelled. But it's handled pretty well in the standard library. So for example, the HTTP request will return immediately or almost immediately when you call do a HTTP request with a context, and the context gets cancelled, the request will return immediately. So it's a nice way of implementing this because it's implemented using a pattern. So, but the pattern is here to pass a context, not some kind of magic. So maybe to rephrase my answer one more time, you don't cancel a Goroutine, you cancel a function using a context object.
Okay.
So the code gets more complicated about this, but if you want to have a performant code, I'm afraid that's the only solution.
Okay, thanks.
Welcome. Here's another question. Here in the third row. Third?
Okay.
Hello.
Hi.
I'm new to Go, and thank you for your talk. I have two questions. First, you mentioned that the writing... I'm just curious. So you mentioned that writing to the map by two Goroutines will cause an error, and I'm just curious, will it be a compile error, or it will be a subtle, sometimes race condition error you see? Like when you try to do this, actually, what will happen? And then maybe I'll ask the second.
Okay, so maybe this requires a mod answer. So a compiler is not able to catch this because I think in non-language I know race conditions are hard to catch using the compiler, so the compiler will not catch this. And what you will see is the map panicking. So the map will panic. This is the situation. So the panic, Go does not have to give this answer to everyone. The panic is a situation which is non-recoverable errors. So for example, when you open a file and there is no file, it's an error because you can recover it. But when you divide by 0, it's or when you have a null pointer, which is null pointer in Go, this is a panic because it's a not recoverable condition. So in concurrent updates to map will cause a panic.
Okay, so my follow-up question will be then, if we if we then go to the example with the map with the map where you cloned it, because I would imagine the usual pattern of mutex or whenever you need concurrency, you just not need a read or write a value. You basically need the read value, check that the value has changed, and then maybe update this. Like atomic is like you want to read and change, or maybe something like this. And I wonder then how would you then do? How do you expand this example with the store to do? Because if you cloned maps into different coroutines and then want you to join or combine the results together, so how will Go help with any of how you would accomplish this in Go?
I'm not. So you are asking how you can go, for example, like when you want to do atomic update, right?
Yeah. So if I could imagine that this program to Goroutines will get load a map, and then at the end of the day, both of them are modifying this, and then you want to store them back.
Okay.
So how?
So the answer is. So maybe I can answer you with code which I once did. So the problem which we were solving is that we were fetching the online updates from one service, and they could happen concurrently to updates. And then there were a lot of Goroutines where this was a map, and there are a lot of Goroutines were checking for a value in this map. So what we did is what we have. We didn't have this load value. We just had get. Like from map, so you get from key for key you get the value, and it solves the whole problem with cloning, because you don't need to clone, you have the ownership of the map, and you have a regular mutex using for the storing. So for updating, what we did for updating is we log the mutex, you clone the map, you update the clone, and then you store the clone, and then you release the mutex.